What's poppin', dogs? Mr. Allen here with some ACT prep focused on algebra in this video, but I got a wide variety. We got some quadratics, I've got some radicals, exponents, all the good stuff, 6 examples, so let's get it started. First one, we have a quadratic. It says when the quantity 2x minus 3 squared is written in the form ax squared plus bx plus c, where a, b, and c are integers, what's a plus b plus c? Or sometimes it'll be worded, what's the sum of those 3 integers? So be ready for any kind of wording there. This is a spot for a classic mistake of Algebra 2 students. You tend to distribute this exponent across addition or subtraction, which is illegal and will end you in math jail, right? You'll end up in math jail in that situation. What you need to do is think about it as 2x minus 3 times 2x minus 3. Okay, and some of us can do this in our head pretty well. I'm gonna work it all out for you guys, just in case this isn't necessarily your forte. I'm gonna do 2x times 2x, that is 4x squared. 2x times negative 3 is negative 6x. And what I'm doing here is distribution, right? Or a street term would be FOIL, first, outer, inner, last, an acronym to help us remember. So you have the negative 3 times 2x there, and then negative 3 times negative 3 is positive 9. Let's clean it up, combine our like terms. I get 4x squared minus 12x plus 9. And now it says, what's the sum of those 3 integers? So 4, basically we're doing this, 4 minus 12 plus 9. Well, 4 and 9 gives you 13, minus 12 is 1, that is C. If you need to, you can always plug it into your calculator. You got it for the whole test. Why not if you want to make sure that you don't make some kind of a stupid mistake? That's the worst thing, you lose points that way, all right? Hope that one helps, guys. Let's keep it moving. So we got some inequalities on this one. It says, which of the following is the set of all real numbers x such that x plus 3 is greater than x plus 5? That seems impossible, doesn't it? Right? If I take a number and I add 3 to it, how is that number ever going to be greater than the same number and adding 5? And it is the empty set, but let's also just talk about why that is. Well, when I have x plus 3 and then x plus 5, if I go to solve this, I can subtract x on both sides, and I'm left with this statement, 3 is greater than 5. Is that true? No. So it is no solution, okay? Initially, it makes like logical sense, but not everybody picks those things up, especially in the heat of the moment on the test. But that's how you would set it up and see, what happens. 3 is not greater than 5, so if you're left with a not true statement, no solution or the empty set. So I got a tricky one for you guys here. We got let m and n be 2 positive integers such that m is less than n. So m, as in Mike, is the smaller of the 2 numbers. Which of the following compound inequalities must be true? It's a little hard to see here with all these square roots. When I see that the square root of m times n is greater than 0, like that makes sense, right? 2 positive integers multiplied together, take the square root, it's got to be greater than 0. But is it less than m? Well, what if I were just to square everything here, okay? Because just like an equation, if I square both sides, that's cool. I can square all 3 parts of a compound inequality. So now I have 0 is less than m times n, the square root's gone, is less than m squared. Well, hold on, isn't n larger than m? And couldn't m squared just be written as m times m? So wouldn't this be bigger than that guy right there? It would be. So I know it's not choice A. Can't be that one. And let's apply the same thing to the next one. Well, the same thing's going to happen, right? It just a 1 is there instead. So this guy's out as well because I'm going to get the same scenario except for this would have been 1 instead, okay? But let's take a look at choice C here. If I square everything, and I'll go different colors here, squared, squared, and squared, now I have m squared is less than m times n is less than n squared. And could I write this as m times m? M times n. I hate when they use m and n for whatever reason, man. Can we just use x and y, right? M times m, those are the smaller integers, is less than m times another integer that is larger than m, is less than 2 integers multiplied together that are larger than the m. This one is making sense to me, right? Let's just put some regular old numbers to it. Let's say that m equals 2, and let's say n equals 4. Just keep numbers nice. Well then, m times m, this is going to equal 4 right here. 4 times 2 is going to be 8. And then 4 times 4 is going to be 16. I could probably try that all day with different numbers, and it will work out. So choice C is what I am going with here, guys. That is a tricky one, but I think squaring everything, getting rid of those square roots, makes it a little bit easier to see what the heck is going on with that one. But definitely a tough problem. If you get stumped on it, don't feel bad. All right, take your best educated guess, and then move on. All right, this one's another doozy. For all positive values of g and h, which of the following expressions is equivalent to g squared times the square root of g to the fifth times h squared times a fourth root of h to the fifth? Oh my goodness. Okay, so let's do some simplifications here. I'm going to work with the g's first, and I'll do that in orange. I could take out 2 pairs of g's there because it's a square root, right? And if I do that, I'm going to get g, whoa, it's a weird g, g to the, well, I took out 2 pairs, so g squared times g squared is g to the fourth square root of g, okay? So that's what I get for the g's. And let's do the same thing here for the h's, shall we? I can take out one group of 4 h's, it's a fourth root, so I can take one of those out, and I've got h to the third then, and then the fourth root of h. But unfortunately, that is not one of my choices. It looks like we're either in a square root or a fourth root, okay? Now, here's where the tricky part comes in. Actually, hold up. Let's see if we can make maybe an educated guess first. Do I see anything with g to the fourth and h cubed? This is the only one with g to the fourth and h cubed. It doesn't necessarily mean it's guaranteed to be the right answer, but it's definitely a step in the right direction. Now, I'm going to manipulate this orange one up here to be in the fourth root. G to the fourth, if I want this to be the fourth root, could I make this g squared? Okay? I'm basically doubling the root and doubling my exponent within, which is then equivalent. And now we can put all of these guys together into one lovely, fantastic answer of g to the fourth, h to the third. Everything's in the fourth root now. We got g squared h, and that is my answer. Whew. Tough, tough. I think your best bet here, if you don't want to get too lost in the algebraic sauce, is doing what I did right up top here and hoping that the g to the fourth and h to the third are there. But if not, you can see how I was able to manipulate a square root into a fourth root and get it to actually work out to the exact answer that we had right there. All right, let's keep moving. So here we have if a equals b plus 2, then b minus a to the fourth is what? Seems a little weird, but it's actually not that bad. Let's take this b plus 2, sub it in for a, shall we? So I'm going to have the quantity b minus, and whenever I substitute, you definitely want to add parentheses around what you're substituting in, because that distribution of the subtraction needs to happen there, or distributing a -1 essentially. So now I have b minus 2 to the fourth. The b's cancel. What is -2 to the fourth power? It is positive 16. Now, if you didn't do the distribution of the negative there, it would have not mattered in this scenario because it's being raised to an even exponent, which is going to guarantee that it's positive. But if this was instead to the third power, to the fifth power, that negative would have come into play there and you would have had the wrong answer. So there we go, guys. Quick, easy substitution. Distribute your negative, evaluate, boom. It's lovely when things cancel out. All right, last one for you guys. We got a literal equation, meaning it's filled with a bunch of variables. We're solving for a particular variable. I have for all pairs of real numbers, m and v, where m equals 3v plus 6. What does v equal? So all I'm trying to do here is solve for v, get it in terms of v. So I'm going to rewrite it right here. We got m equals 3v plus 6. I'm going to subtract 6 first. So we have m minus 6 equals 3v. What's our last step here, guys? Divide by 3 on both sides, and I get v equals m minus 6 over 3. Do we have that answer? Yes, we do. It is choice J. Now, I do want to point out, because I see like how some other answers are written, sometimes they'll actually write it like this. They'll keep it as m over 3, but then they'll do minus 2 off to the side. They'll simplify the other one. So just in case an answer is written differently on your ACT than what this one is right here, I got your back. All right. And thank you guys for watching. If you're still watching, you're awesome. You're fantastic. If you have any questions, feel free to pop them in the comments. Let me know. If I can answer it, I'll answer it there, or maybe I'll make another video for you. But otherwise, you guys, thanks for supporting the channel. Have a wonderful day, and good luck on your ACT.